A very good afternoon to all our dear customers and colleagues and employees of our distributors. This is Sanjay Vera, Head of Marketing from Tata Steel. Today webinar session is on industrial liquid coatings, which are the requirement by various industrial organizations, and what are the best trends on the as far as global best practices are there, which will be detailed by Mr. Meghan Manjrekar, who is having almost more than 35 years of rich experience in this field. So best wishes for the session, and also please feel free to ask any query or questions during the webinar sessions. He will try to reply as much as possible. Thank you.
Good afternoon, everybody. I hope you are in good position to listen me in the first place, and secondly, good position to see me also. This is a presentation we are running on industrial liquid coatings, industrial protective coatings, what also it is called as. And here what we need to understand is there are a lot of good opportunities in export markets, and unfortunately we Indians are not so good in coating areas, and we fail to meet the global expectations. So this is a small effort from our side, Tata Steel side to just give you some inputs on what should be done, what are the do's and don'ts while doing this liquid coating, and how to go about it. Second thing is you are all invited to ask the questions, but these questions, your voices are muted, so I'll not be able to listen to your voices. But on my right side of my screen, I can see you are asking me the question. I will read them out, I'll answer them, and I would like to make it as much as a interactive session as possible. So I think I can start. First few photographs of what are the products being coated. It could be ships, it could be different types of industrial products, pipes, heavy machineries, PHCs, transformers, big tanks, some offshore installations, some skid mounted equipments, to day-to-day industrial equipments like compressors or molding machines or things like that. Everybody needs steel. There is a good potential in India. Various products are manufactured from steel material, HR and CR, and are coated with liquid paints. These are technically excellent. The product as such are technically very excellent, whether mechanically or electrically. But when it comes to coating, unfortunately they fail to impress the export customers. And when they reach the other ports, other shores, the containers are open. The first thing the customer observes is rusted objects. Then rejecting it either or blacklisting the manufacturers. So this particular presentation today, we will be discussing the vitals of coating in certain cases or in some such cases. Normally problem faced, you can see from the photographs, usual customer complaints are peel off, blisters, corrosion, and aesthetically they are not up to the customer satisfactions. I've just shown a few photographs on the screen, but they are not all. There are many complaints. Few complaints may come immediately, few complaints may come after 3 months or 6 months. We will try to address these problems basically. Before we go into this coating technology, why we do coating, we should understand corrosion. The basic corrosion rules are moist air is more corrosive than dry air. Hot air is more corrosive than cold air. Hot water is more corrosive than cold water. Polluted air is more corrosive than clean air. Acidic air or acids are more corrosive than bases, that is alkalis, and salt water is more corrosive than fresh water. Now, what is corrosion? The simplest possible definition of corrosion is we get metals in mines as minerals. We put a lot of energy onto it and convert it into pure metals. Now, this metal has a tendency to go back to its original form, that is the natural form, as say iron going back as iron ore, and that is what we usually call as corrosion. So, it is difficult to control the corrosion, but we try to delay this process going back, and for that we need good coatings. First of all, you'll have to refer to one ISO standard, which is ISO 12944. This is an international standard referred by the global customers, and it's a very comprehensive uh, standard. In that, again, one of the volume you will find classification of environment, where atmospheric corrosivity categories are given, where C1 is very low, C2 is low, C3 is medium, C4 is high, C5I, that is very high industrial, C5M is very high marine. So it becomes very important to know where your products are going and what would be the service abuses, what will happen to it during the service of that particular equipment or components. That is very important to know. And when you refer to this, you decide where my equipment is going to go. You can select a better coating system which can give you good amount of resistances, warranties you can give. For example, in India, the certain industries are giving up to 25 years of outdoor warranties. And these are, of course, extreme conditions, but it is possible and you can achieve it. Now, coming to protective coatings, there are three types of coatings which are usually used. Uh, these types are, first, we call it a sacrificial coating. The sacrificial coating functions in similar fashion as a cathodic protection. This coating itself has mainly zinc, which functions as a sacrificial anode. So sometimes we mix this zinc powders in the primers, or if I need some more corrosion resistances, I can spray it, what we call as zinc metallizing, and then apply the next coats. Second is called as barrier coating. These barrier type coatings function by creation of a near impermeable barrier which insulate the substrate from corrosive agents. Now, any paint has some amount of permeability and moisture can pass through, and then we will have corrosion problems. Third, what we call as inhibitive coating. Now, these inhibitive coatings are something similar to barrier coatings, except they contain some inhibitive pigments in this coating film. Certain pigments like zinc chromate and all are now banned against ROHS, and especially on exports you cannot use this. So these are replaced by some pigments like zinc phosphate and all. So these inhibitive pigments are there in the coating film, and they will create ions which will passivate when they come into contact with humidity or moisture. So that when they passivate, they will protect the film from corrosion. Of course, in this all three, the sacrificial coating, the first type of coating, you have the highest corrosion resistance, then comes barrier coating, then comes inhibitive coating. So depending on how long you are looking at your product life, you can choose these coatings. Now, another main parameter for selection of coating system, reference to ISO 12944. First is the environment conditions which we saw C1, C2, C3, C4, C5I and C5M. Uh, Again, in that we have to check for micro environment and macro environment. In the sense, macro environment is something going to place like Mumbai, where there is a corrosion overall. So anywhere in Mumbai it's going to corrode. But a safer place, a dry place, for example, say Bhopal, Nagpur or Jaipur in India, uh, the corrosion uh, conditions are not so stringent. But if you are putting it in a company where there are acid fumes or some other kind of pollutions which can corrode, then you have to take that also into consideration, where we call it as a micro environment. Working conditions of that machine, then if I want to repaint or recoat, what is the available downtime? Next is what is the appearance expected by the end customers? Then what is the anticipated life expectancy of that structure? And then the budgetary constraints again. So all these three will definitely help you. If you get this data from your end customers, probably you'll be in a much better position to select what kind of coating to be required, and that can really become cost effective coating, giving you the right life or right solution to your problems. Now there are some good process recommendations which we will be going through the next slides. Important stages in protective coating. First is surface preparation, second is mixing and thinning operation, third is coating application, and last is in-stage inspection, which is equally important. And you can literally record everything. Plus, you can take photographs now. Taking photographs is now easier because of our cell phones. Almost all cell phones have cameras. So you can take photographs of various stages and you can preserve them as a documentary proof also. So usually if you are getting your complaints late, let us say after 6 months or 1 year, you can definitely go back to the records, take out the reports, and you can really come down to a reasoning why it failed. Uh, this kind of traceability, if we can impart in our reporting system, it will definitely help us a lot to improve in future. Now, surface preparation. Mechanical pretreatment is called as surface preparation. Objective is to clean the substrate of all impurities, foreign matters that could affect the performance of coating systems. Creates a surface profile to the substrate, to the metal, which increases the surface area of the substrate and creates a tooth for the coating to adhere to. These processes are used mainly in protective coating industry applications. Type of surface preparations used for pre-treatment of metals before coating. First is solvent cleaning, which is mandatory for all the below listed uh, processes. If I have some small jobs, not high volumes, I can go for hand tool cleanings like wire brushes, memory papers, etc. etc. If I have little more productivity, I can go for power tool cleaning. Power tool cleaning, you can get sanders, sandpapers run by either electrical or pneumatic tools. You can also go for some cup brushes, wire brushes, which are rotating and cleaning. If you still have your still more productivity is there, you can go for blasting. They can be either shot or grids. We'll detail it later. And the new generation cleaning, which is called as high or ultra high pressure water jetting. Normally, this is used in very few places, very controlled conditions, because the pressures are from 15,000 psi to 25,000 psi, which is extremely high, extremely dangerous for the people who handle these equipment. So we have to have a very very highly controlled conditions, then only we can go for this. Uh, Shipbuilding industry has already started doing this for some time. Chemical pretreatments. There are two methods of pretreatment. First is mechanical, what we just saw, and second is chemical process. In chemical process, what we do is we remove the impurities using chemicals, and we enhance the surface for the coating. Selection of method will depend on type, shape of article, and corrosion resistance requirement. And there is some more considerations as well. Now there is a thumb rule that the mechanical pretreatment is normally preferred for HR, that is hot rolled steels and castings, and chemical pretreatments are normally preferred for CR sheets and HR pickled material. Now what happens on HR, you will find a lot of mill scales, and these mill scales can only be removed while you do some mechanical pretreatment like blasting, or you can pickle it with very high concentrated acids, which is again not a very highly recommended process, because sometimes if you are doing some deep draws on pickled material, they might crack because there's something called as hydrogen embitterment, which happens while we do pickling material. So usually first preference goes for blasting. Now this is something about chemical pretreatment. Then we have a traditional 7-tank process, which we call as chemical process or chemical pretreatment. This process involves 7 reaction tanks, which has its own definite role. This process can be changed or altered in respect to number of tanks or stages depending upon the job geometry, contaminations, production rates, etc. The reactions in these tanks can be at room temperature or at elevated temperatures. These elevated temperatures have two advantages. Number one is reaction would be faster than the colder process, so you will have lesser takt time. And second is the takt time in all the seasons would remain same, hence same quality throughout the year. So now what happens usually, a place like North Indian parts, the winter temperature could reach up to 2 or 5 degrees, where the water temperature might be, the tank bath temperature might be 10 degrees, and in summers it reaches 45, so it might be something like 35, 38. So you cannot expect the same reaction to happen in the same fixed time. So normally we prefer the temperatures which are higher than the maximum temperature of that area. Now I'll just explain you a little bit about the 7-tank picture which you see on the right. First stage is normally degreasing, where we are removing all the grease and oil. Along with that, whatever debris, whatever dust particles are sticking to that metal will get removed. These are mainly alkaline tanks. Alkalis are there which are reacting with the oils. Oils are long chain fatty acids. So alkalis are better to react with them. With the reaction is called as saponification. Then there may be few oils which we use. These oils can be hydrocarbon oils or petroleum oils. They will not react fully with alkalis. So we have to add some amount of surface active agent or surfactants, which will emulsify these oils and remove it from them. Now, if you have very complex job, you have smaller takt times, you can always go for 2 degreasing stages. The first one called as pre-degreasing, or also we call it as knock-off degreasing or KOD. Then the second stage comes as water rinse. Now again here the water quality for all these tanks need to be very good. You must have experienced that place like say Kolkata, Bhopal, even Chennai, lot of other places where the hard water comes through taps. If you try to take a bath with normal soaps available in the market, you will not get a good foam. Naturally, these reactions will not happen if the TDS or total dissolved content or the hardness of that water is high. So take care of your water. If you are using bore water, you please take water testings, test reports every month so that you know which season water is within range and which season it is out of range. So you can put something like RO purifier or something. No need to go for DM unless your system demands it. RO can work better. RO can give you industrial water quality for normal pre-treatment reactions. Then you have derusting where we are removing a lot of oxidations. This is different from pickling. Pickling will have very high concentration of acids. Derusting does not have that high concentration of acids. It will only react with the surface or flash rusts which are created especially in monsoon seasons, especially where you are doing some grinding work after welding. These areas you will find a little bit more rusted. This rust can be taken care of. But again, this derusting will have a lot of corrosive fumes coming out of this tank. Not good for the human being operating in that area, not good for other parts kept in that area. They can rust just because of fume. Even your industry shed, factory shed can rust. New lines, especially the automobile lines, they do not have derusting there. They see to it that the jobs reaching paint shops do not have not even a single spot of dust anywhere, rust anywhere on that, and it is usually called as BIW, body in white. So you can just imagine it as totally rust free when it reaches. After that, again, water rinse is there. Now, all these water rinses you can have instead of one, two rinses. So the rinsing would be better, and the second tank will always remain within the demanded pH by your chemical suppliers. So close to 7 you can have. Now, when derusting is removed, next water tank also will get removed, and what you will have is you need to activate the surface for phosphating reaction. So one tank is added in that case. In the new lines where derusting is removed is called as activation tank, surface activation tank. So one dip there, then you go for phosphating, and phosphating again you have 2 or 3 different types. One is iron phosphating, second is zinc phosphating, and third is manganese phosphate. Manganese is not used for coatings, but zinc and iron are used. Now iron is not will not give you as much as corrosion resistance as your zinc phosphate. So normally zinc phosphate is preferred from the corrosion resistance, and ultimately the cement tank, again there is a water rinse, and the cement tank is called passivation. Now this is again, if you are exporting chromic acid, passivation not to be used because chrome is banned. So you will get chrome free passivations also. Now why this passivation is there is after phosphating. In phosphating is actually a crystalline structure, and these crystals are usually needle shaped. So there could be some gaps or micro gaps within that crystalline layer. So this passivation layer is going to temporarily close those. Now one more question is how much time I can stop or I can have between phosphating this total stage and first coat, primer coat or first application coat or powder coat. So usually depending on weather, again, if the humidity is below 80%, you can put it up to 8 hours. If it is more, less than 4 hours. But sometimes I've seen in most of the shops, one batch or one basket or 2 baskets will be there, which are at the end of the shift, and next day morning they'll process. Not a very good idea. It can lead to certain problems. So basically, if possible, you can stagger the shift for this pre-treatment people and stagger the shift for coating people by say 15 minutes or half an hour depending on your productivities, and that could solve the problem, and your qualities will be in much controlled, sustainable controls. After passivation, if the water lingers on the job, you are going to have a rusty feel or a flash rust, what we call. So you have to have one water drying oven if possible. If not, another idea is heat up the passivation chemicals or that bath. So the job will pick up the heat. Once it comes out, immediately air blow the job so it is free of water. So this way, either or you can solve these problems. Now this is something very important is surface preparation, and surface preparation we are again uh, not very technically competent. I'm talking of most Indian industries I've been visiting. As far as the chemical process, yes, we have some technical know-how, and the chemical suppliers are there to support. But here there is nobody to support. The person who supplies you the grit or shots, he will not be giving you a support which a chemical suppliers would be giving you on normal basis. So objective of this surface preparation is to clean the surface of all impurities, meal scales, sometimes rust, foreign matters that could impair the performance of coating system and shorten its service life. So we have to remove those, clean the surface, and then impart a surface profile to the substrate which will increase the surface area of the substrate and create a tooth for coating to adhere. So you'll get better adhesion when you have a very good surface area created, more surface area created, and surface profile is good. So basically, there are some international standards. At the center, you'll find there's a small table. You can get them on internet. There is one ISO, or earlier we used to call it as a Swedish standard, where we call it as SA1, SA2 and a half, SA2, SA2 and a half, SA3. Equivalentness and equivalent SSPC are also given. Um, Basically, SA3, we call it as white metal blast. That is, if I cut one HR sheet by an hacksaw, the inside metal what I see is what we call as white metal. So SA3, I am removing so much of layer of impurities from the surface so that that white metal is seen. SA2 and a half, we call it as near white metal. So you can see some gray patches and some white patches onto that. But these gray patches are out of these mill scales, but they are adhering to the base metal very nicely. So it's not very easy to remove those, and mostly normally in many of the specifications you'll find the specification for blasting given is SA2 and half. SA2 is industrial blast, and SA1 is what we call as sweep blast or very fast blast. Usually we do it on uh, hot dip galvanized materials or galvanized materials where I cannot have more of mechanical actions, otherwise we will end up removing those zinc layers which are there for protection. Now there are some comparators. On your left you can see the cleanliness comparators are there, which for grit they will be different, for uh, shots they will be different. You get different types of certified grit from various agencies. You can keep it on the blasted surface and you can check it. Now along with this specification SA1 to SA1, SA2, SA2 and SA3, This is only for cleanliness levels. They do not talk about what should be the depth of profile. So in any specifications, if you see correctly, you will find two parameters given. One is SA2.5 and second is the surface depth. Surface depth should be can be 30 microns, 60 microns, 80 microns, but again it may become SA2. So this way it goes. Now on the right you can see a picture which is surface depth gauge. Now there are both analog as well as digital type of gauges available. Uh, Preference should be given to digital because zeroing and getting the reading is easier. In analog type, I have seen even engineers getting confused because you are checking the depth. So naturally the hand will move in a different direction than they are used to on your micrometers or other gauges. So they get confused also. So better to go for a electronic type depth gauge. Now surface preparation and service life. This is very important to remember. The degree of surface preparation employed will have a significant effect upon the lifetime expectancy of the coating system. In marine industries, usually they spend almost equal amount on blasting what they are spending on the coatings. Three coats. The costing almost comes to same. Here basically we are trying to save money on blasting. Lot of big companies I've seen specifications talking about sandblasting. Sandblasting is banned in India in 1968. Unless and until you do it under controlled condition, man should not be there because the dust created by sand is carcinogenic. Uh, you can expect cancer if somebody is working in that area. That is why it is banned. So there are many more different types of medias available. Usually on metals we prefer either shots or steels, and sometimes on stainless steel or aluminium there is a specification saying that they will need a non-ferrous materials. Usually the steel balls or grades are CI, stainless steel. Then usually there is aluminum oxide or garnet or some kind of natural materials are also available, but not sand. Then on the extreme right, you will find one called SSPC VIS1, dry abrasive blast cleaning. That is VIS1, VIS2, VIS3, up to VIS4 are there. For different types of blastings you do, that is for grid it is different, for shots it is different, for water jetting it is different, like that. Now in this what they are doing is according to ISO 8501, the incoming material rust levels are designed as A, B, C, D. And on A, if I do SA2, SA1, SA2, SA2.5 and SA3. On B, I do the same. On C, I do the same. And D, I do the same. Those photographic booklet is there for reference. So normally when you get the material for blasting in your shop, usually you have to check the preconditions, photograph it, compare it with this is a visual standard, compare it with this and record it. So it is a C grade rust available. So on C grade if you do SA2.5, it is not going to look like SA2.5 on grade A. So naturally, if there is a third party inspection, there will be a confusion or a problem. So he'll keep on asking you to blast till the time he is not happy. But if you record it correct and show him the photograph from this book, probably those fights can be avoided and extra work can be avoided. Another thing is what should be the surface profile depth? Because there's a big confusion in industries. Usually we recommend 40% of primer DFT should be your surface profile. So for example, right side you see both the photographs. On blasted steel you have a very low protection of the primer. Suppose it is my surface depth is 40-45 microns and I am putting only 50 microns of primer. So on peaks I will have 5 or 10 microns or 8 microns of thicknesses which are going to have low protection and ultimately they are going to convert to a spot rusting. So on a plain white panel you might have seen small pinpoint rust that happens usually because of this. And second picture you see is there is enough protection or enough thickness of primer, so the protection will be definitely better. So a thumb rule is it should be at least 40% of your primer DFT. If it is more, you cannot control it, then you have need to increase your primer DFT. So in short, more the surface profile, your paint consumption or other primer consumption is going to increase. So basically try to have a look into this. Now there are some few slides where we are talking of surface preparation, what extra care needs to be taken. First and foremost thing which I have already said is mandatory is to removal of oil and grease. Should be carried out accordance with SSPC SP1 by solvent wiping. There could be other, apart from solvents, it could be immersion cleaners or other things also. The recommended solvent or solvent wipe is usually MTO or xylene or some other slow drying solvent. MTO full form is mineral terpene oil or which is available in the market, and GP thinner, general purpose thinner. So you can buy that also, but it should not be contaminated. It should be in good condition. Now, one more thing to note here is usually people will cut some carbide or old paint in and try to put the thinner in that. Then they will have one cloth rag which they will dip into, clean, again dip into the same, clean, again dip into the same. Naturally, you will be contaminating that solvent with oil, and probably you will end up putting that oil onto some certain surfaces where there was no oil earlier. So they have to take it in a bottle, puncture the bottle lid, and just pour it onto the cloth and then remove it. Another thing is they have to apply with one cloth and they have to wipe it with a dry cloth. So that will serve the purpose better. Now, how to check it? A very simple test is you can have a water bottle with a spray like the barber has. Spray it on the surface. You can see the photographs on the right. The top photo will show shrinkage of water. That will tell you that the oil is present there. And the photo at the bottom, you will find a clean film of water which will give you an indication that oil has been removed. If you don't remove the oil with blast, with those grits, you are going to push it inside the depth, which is going to give you a problem in future. I'll again request everybody that anybody has anything to discuss or ask questions, please type them out, because while going this, if you ask the questions, they will be in the flow. Otherwise, if you save them for the end of this presentation, probably something might miss out. Okay, so please ask the questions whenever they come to your mind and type them out because your voices are muted. Another thing, another extra care to be taken is compressed air quality has to be clean and dry. Now there is a test called blotter test. You will find it as per ASTM D4285. I'll just repeat again if you want to write. ASTM D4285. A simple test. Actually, you can perform it regularly. You can also perform it for if you have air spray guns. If you have air spray guns, the air going to the spray gun, you can check it in the same manner. Or even for powder coating spray guns, whatever air we are using, you can check it the same way. A clean white absorbent cloth should be attached to a rigid frame. Nozzle is at 18 inches away. Approximately for 1 minute, and one of the other specification, it is also written as 90 seconds. So 1.5 minutes also is written in some other uh, standard. After the test is complete, you should look against light and see if there is any transparency in that particular cloth. If there is a transparency, definitely oil or water is there in the air. Wait for some time, the water will evaporate and still you are finding the transparency. Uh, the, these are the traces of oil which are coming and not getting evaporated. So this is an important test, and usually we say we have a very good compressor, then we have a very good dryer, we have a very good system, we have FRLs. FRLs are not going to remove all the oil or water, especially oils. And then we face certain problems and we look for the solutions elsewhere, not at our pneumatic lines. Um, Most of the people nowadays are preferring refrigerated uh, dryers, air dryers, compressed air dryers. One thing you have to check there is the outlet of that. Usually it's a metal pipe. Just hold your hand, check the temperature of that, and it should be below ambient temperature. It should be cooler than the surrounding temperature. That means whatever can condense has already condensed. If it is warmer than that, then the air will go into the pipeline, cool down, and some more water will condense, which will trouble you. So these are few tips you should uh, consider. Then another thing which we don't again look into is whether my media, that is either shot or grit, is clean or not. There are again standards for metallic abrasives like SSPC AB2, which are recyclable medias, SSPC AB3 for normally for ferrous metallic abrasives like CI grit and other things. You'll have to buy these standards from SSPC, they are available on that. So now this particular wire test is you have to take some amount of grit into a bottle. Even the normal water bottle is good enough. Fill it up to fill it up this much by the grit. Uh, Taking it from your production, have water to this level, almost 2/3 of the bottle. Shake it vigorously and keep it for 20 to 30 minutes. The grit will settle down. If grit has dust or any other things, there will be a turbidity in the water, and on top of that water you will be able to see oil floating. So that is a condition, either you have to clean the abrasives or you have to change them, because this is going to create a problem, because it is going to deposit either contaminations or they are going to deposit oils, and that is going to fail your paint films uh, very early. Third thing to check again is whether there is dust on blasted surface. It's a very simple test. You take a clear adhesive tape 1 inch wide, 25 wide, put it on the surface, just pull it out, paste it on a plain white paper, and on the right there is a chart given. This is from ISO 8502-3, and you compare what is the dust level. Now again, in certain standards, customer specifications rather, they will say that it should not be more than 2. So if it is 3, 4 or 5, you either have to vacuum clean it or you will have to air blow and remove it. But this is coming out of your media. So better clean the media or filter the media so that this dust will not trouble you. Then these are not done in usual cases. These are only done where you need some very high level of corrosion control. If it is going to your machines are going for offshore or something like that where you need very high degree of corrosion resistance. Usually we check for chemical contaminations. This will be required by the specification from the customers. Uh, there are a lot of tests, literally number of tests, probably hundred of tests, 100 different tests are there. What I've given here is something very popular. One which we have is a sticker, and on that sticker there is a latex. This you inject 2 ml of water inside, clear water inside, let it be inside for 40 minutes. Then you just take out with a syringe and check with several methods again. One thing is you can check the conductivity of that. If the conductivity is high, naturally some minerals are getting dissolved into that water. Something like chlorides or ferrous ions or sulfates or nitrates. And these water soluble contaminations are going to give you a problem which we call as blisters. Because what happens is I have this surface, then I have a say one salt here, and then I coat onto that. Now, as we have already earlier discussed, these coatings are semi-permeable. They are not porous, but they are semi-permeable. There is a permeability there. So when that will be there in constant humidity conditions or under rain, uh, that moisture is going to go travel inside those films, and usually all these salts are hygroscopic. They are going to absorb moisture. So what will happen is it is going to dissolve, and then once a salt solution happens, it osmosis is going to start and it is going to pull the water at a very high or very accelerated high fast rate, and you are going to have a bubble there which we call as blisters, and inside metal will be corroded. So that is why we check this. Even in high-end 7-tank chemical pretreatments, the last tanks usually recommended are DM water. DM water is demineralized water. So where there are no contaminations or minerals in that. So naturally what happens is whatever water soluble contaminants are there, they are removed before we coat them. Another thing is checking and recording the ambient conditions. Now these ambient conditions are like check for ambient temperature, check for relative humidity. Now what happens if the relative humidity is higher? That is, you go to coastal areas in India, try to take out the bottle from your fridge, immediately there will be a water condensation outside the bottle. That doesn't happen in areas away from seashore, but during monsoon it does happen. Or or sometimes in monsoons evenings or even winter evenings, you will find some condensation on your scooter motorcycle seats also at sunset and sunrise, morning time and evening time. This is what happens on your jobs when you blast it. So we are usually recommending to check ambient temperature, relative humidity, then from relative humidity you can find the dew point. Dew point is the temperature where the water will get converted or condensed into water. So, and we also check the job temperature. Now on the right hand side, first you can see uh, today's generation is really very fortunate that these electronic things are available. So on one particular meter or gauge, you can find the ambient level, wet bulb temperature, dry bulb temperature, relative humidity and dew point all together. But earlier, probably 10-15 years back, you had to have those psychrometers with wet and dry bulbs, and you have to rotate it for some time and then check it. Then take out a book, refer to that particular page, and then you find out the RH. Then same thing you have to do for dew point. Here you get something very fast within no time. Okay, and the picture on the right bottom is a magnetic surface temperature gauge. So you just put it on the surface of your job. It can be before blasting, after blasting, both, and check the temperature. It should be higher by at least 3 degrees, minimum 3 degrees than the dew point temperature. Then you are safe that the condensation is not going to happen on your jobs. Few more things, extra care. One is, if the relative humidity is more than 80%, stop operations. You are not supposed to blast. Okay. Or have controlled conditions, installing a dehumidifier or things like that. Ideally, blasting should be done at daytime, sunrise to sunset, where you are outside, but inside the plants you can definitely have controlled conditions. Then there is no issue. But outside, if somebody is doing, say, in the near to seashore, especially in the dockyards and all, evening by 4, 4:30, 5, they stop blasting. Whatever is blasted, they'll put a primer and then they'll keep it for next day. Then blasted surface should be coated within 3 to 4 hours, whatever is the relative humidity, with the first coat, say primer. Your report should record the process time as well. When you did blasting, when you started doing blasting, when you finished the blasting, what time you started primer, when you finished the primer. These things also should come into your report. So it's better for you to have some traceability. If at all you have to find out the root cause of some failure, which you may get after 6 months or 1 year or 2 years. Second thing is mixing. Use the correct mix ratio recommended by the paint manufacturers. I've given right and bottom, I've given some examples. They are writing mixing ratio 3 volume base part A to volume curing agent part B. That is base to hardener 3:1. You have to do it correct volumetrically. If you are getting, say, 20 liter 4:1 as one container having 16 liters of component A and other container having 4 liters of component A, at the end of the tins, probably you will find that some of the container is not fully empty. That gives you an indication that something is not happening correctly. So you have to have a good control over this mix ratio. If there is higher amount of hardener, the film is going to be brittle. If it is still higher, it may crack also. If it is on the lower side, usually that film will be soft and naturally you will have a lot of scratches. If it is still lower, the film will come off, adhesion will be bad. Now, normally we are guided by our painters in our shop, on our shop floors, and what they will say is, uh, want to dry it fast. Today it's winter, very low temperature. So let's add more hardener, it will take care of that. No, you cannot do that. Whatever is written or whatever is recommended by the paint supplier, we have to religiously follow that without asking questions. Nobody can ask the question, nobody can change the things. Try to use power mixer for proper material mixing, because especially these protective coatings have higher viscosities. So better to mix both hardener and base and hardener under power stirring. It's very simple. Usually go for a pneumatic stirrer, and you can make it also. There are power tools available. You can buy one, say power screwdriver, and you can have an attachment which can work as a stirrer. Second most important thing is observe pot life. Now, what is pot life? Pot life is like everyone must have used M-Seal sometime in their life. If I mix the M-Seal, say whatever they say, cut 1:1, mix it, and then you can start molding. I mix it, keep it, go for lunch, come back and start working on it, it will not work. Right? Why? Because there is some reaction happening between that hardener and base. It's what is called as cross-linking or further polymerization, and it's going to make hardener. So usually pot life in case of 2K paints, 2K stands for two component paints where base and hardener are different. Thinner is not considered as a component. Okay, the reaction is going to start and it is going to end. So normally in case of 2K paints, we say that whenever the viscosity of that paint is doubled, that threshold time is called as a pot life. Before that, you have to apply the paint. Now, again in that, they will write 4 hours as pot life. Usually, ideally, we have it 4 hours because it is half shift what you get till lunchtime. But if you these all reactions, all chemical reactions are temperature sensitive. Usually, as a thumb rule, what we say is increase in temperature by 10 degrees centigrade, the speed is going to double. So that means those 4 hours at 20 degrees centigrade are going to become 2 hours at 30 degrees centigrade, going to become 1 hour at 40 degrees centigrade. Okay. Look at the last table at the bottom right side. -5 degrees, the pot life is 9 hours. 5 degrees, pot life is 7 hours. 25 degrees, pot life is 4 hours. 35 degrees, pot life is 2 hours. So you have to check what is the ambient temperature. Accordingly, you have to inform your painter what is going to be the pot life of that. And usually, again, we also have a term called workable pot life. That is, 50% of the standard pot life mentioned should be your workable pot life. Normally, what our painters will do is they'll mix the paint, then probably they will work for some time, go for lunch, come back, they'll find the viscosity is picked up, they'll add thinner and apply it. That is not a good practice. Ask them that first, whatever you make, you should be able to finish it. So, or rather, otherwise, whatever you would be able to finish it, that much paint only you mix and finish it, then you apply second. I get a lot of queries about customer complaints that we have sent a big structure and only some 10% of the corners were rusty, rest of the uh, structure there was no rust at all, no problem at all. So this is a clear-cut case of uh, painting after pot life. So please take care while using all these two component paints. One is mix ratio and other is pot life and proper mixing. These three things will help you a lot. These paints are much better than the old generation paints what we used to get. They are expensive as well. But if you don't use it correctly, you will not get the service life out of these paints and you will face problems. Some more care is you will get some product data sheets from your suppliers. Read them carefully, note them, and do not try to avoid what they are saying. That is pot life and there are a lot of other things which will come. There's going to be drying time, there's going to be recoatability period and all these things. So try to follow everything what they are mentioning. Second thing is stirring of component A and component E again with power mixer before you mix them, because there are pigments in that which will settle. Now all these pigments we talked about earlier is like zinc we are mixing externally, but zinc, phosphate and other pigments are heavier, so they have a tendency to settle down. So if you do not disperse them again, that pigments are not going to work and naturally you will not get the full potential benefit out of that particular thing. And again, what we discussed in the earlier slide is do not mix more material that can be used within the expected pot life. So if you take these things into consideration, I think there should not be any problem using these paints. Now during primer applications, there's something which is called as stripe coat. You can see in the right hand side picture 1 and 2. See, wherever we have welds or bolts or rivets, nuts, some flanges, corners, where if we have to reach by a spray gun, it becomes very difficult to reach. Then if I want to reach there, then probably do it from these areas. The top areas and other flat areas surrounding get very high DFTs or high thicknesses, which are again not good. So usually it is a good practice to do stripe coat with brush and then start spraying. So you will get proper even protection in these areas. Welds also will have some ripples and other things where spray cannot reach, and there are the areas from where we start getting our corrosions. So these areas will be well protected. Then you can start doing uh, check WFT during application. WFT is wet film thickness. This right hand corner you will find one picture where these WFT gauges are available. Now again, going back to the earlier slide, I mentioned that have the product data sheet from the supplier, paint manufacturer. Now this product data sheet will also tell you volume solids. That means after evaporation of thinner from that paint, how much volume is going to remain as a paint film, dry paint film. Taking that into consideration, you have to use this what WFT gauge, wet film thickness gauge. It is a comb type. There are two other types also available in this. Now I have to spray and immediately I have to dip it and check. On that you will find here it is 1, 2, 3, 4, 5 in this picture. Those are mils. One mil is 25 micron. So 25, 50, 75, 100, 125 are there on this gauge. You get it up to 2000 microns also. Now if I have 60% of volume solids and I am getting in this case My third, that is the tooth under 3 is touching the coating, fourth is not touching, fifth is not coating. When I look it from this angle, I come to know that up to this much the paint is there. So 3 means 75 microns is getting touched. Now 60% of 75 microns is going to be the dry film of that particular coating when the solvent evaporates, because 60% is going to be the volume solid of that particular coating. So 75, 60% of 75, something like 40, 42, 45 is going to be your DFT, dry film thickness. And normally I have seen that the specification says, say 100 microns of zinc rich primer epoxy, then 150 microns of micaceous iron oxide, what is called as MIO popularly, and 40 to 50 microns of polyurethane. Now this top coat polyurethane is going to give you outdoor resistances. What we do is the zinc is going to give us some uh, benefit, that is the cathodic protection or sacrificial coating, which we discussed in earlier slides. MIO is going to give you a barrier coating, and the top coat polyurethane is going to give you aesthetics and sustenance against the ultraviolet rays and other things. So outdoor resistances you are going to get. Now, how much is the total? 100 plus 150 plus 50, so 200 microns. Now, when it comes to final DFT checking, we realize that it is only 150 in certain areas. It's going way below the expected by the customer. So we make it up by applying the final PU coat. Now this particular thing, one thing is we are not giving the enough thicknesses to earlier coats which are going to give you protection. And we are going to increase the DFT of the final coat, which is not going to give you that much of corrosion resistance. And secondly, these top coats are also more expensive. So we are end up spending more money than the primers. And ultimate corrosion resistance is not going to come. So using this WFT is also very important. During coating application, you need to understand few things. Too thick coating develops traces in the coating which lead to cracks. There's something called as mud cracking, what we say, especially in case of inorganic zinc silicates, you'll find it. Most of the other coatings also you'll find it. With inorganic zinc silicate, they are very much seen. They are very pronounced. But in certain other coatings, it might be hair cracks or something, so which probably will not see it by eyes, bare eyes. Uh, Too thin coating provides inadequate coverage, which leads to premature failure because there is not enough corrosion protection. Now ensure application of primer within specified time after surface preparation. That is what we have discussed. Then observe specified recoat intervals. Now these recoat intervals are also very important. Some have say 6 hours at so much of ambient temperature to 36 hours max. If you do it beyond, usually epoxies we prefer because they have a very good chemical resistance, very good corrosion resistance, very good water resistance, etc. etc. This epoxy after full curing is not going to accept the further coat. That is why it gets blocked. So naturally they say that you apply before certain time, before it completely polymerized, and otherwise you will not get intercoat adhesion. So naturally you might have seen some problems, or there was one photograph also earlier if you remember, that the primer coat is intact and top coat is coming like a peel of banana. This is a clear-cut indication of they have not observed the recoat intervals. So that is very important. In some case of primers, you will find the recoat interval other side open. So even if you do it after a week or 1 month, there is no issue. But this you need to read it on the technical data sheet, discuss with your coating supplier, and then you will not have any problems. Then ensure specified coating is applied. Please avoid using market thinners. Buy the thinners also from the same supplier, paint suppliers, so you will get better protection. There's no questions there.
No question.
How much time? Okay, there are a few questions here. Mr. Saurabh Srivastava is asking, is there de-rusting process required for online process where no chances of rust in the part? No. In fact, rather you should avoid that. And you can go for offline de-rusting if few of your parts are having problems. These chemicals are available with chemical suppliers. Then, sorry, I missed on some of these. How to clean the surface in fastest method. Damini Mehta. Uh, Basically, cleaning a surface on HR, you can have automations also. There are automatic machines, blasting machines are also available, which can give you a very fast uh, method. Then, which is the best method for zinc Fe alloy plating to pass more than 500 hours in salt spray test? Okay. This, of course, is not a question related to the topic we are going, but iron zinc alloy plating will never give you this. More than 500 hours, there are different types of coatings available in the market. These are basically zinc flake coatings and other things, not the plating. Plating will not serve the purpose. Can we use, Mr. Sahil Agarwal, can you use the solvents on forged pieces before powder coating? If your forged pieces do not have sharp edges, you can use, because otherwise the cloth lint will get stuck into that and there will be some other problems happening, but you can use solvent cleaning there. Digvijay Patel, or is there any other process to resist from rust? Yes, there are many methods to resist from rust. What we are talking is specifically coatings today, but there are few more methods like electroplating or other methods are also there, but we are not covering those today. Mr. Anand Bhagwat, we are using alusing 2 mm, 1.5 mm on our products in case of IP23 compartment, okay, where this alusing sheet used at edges we find rust. What could be the coating process to avoid the rust in this case? Yes, on GI and alusing, when we cut it, usually, again, what is the cutting method? That is also important, because if you cut it with flames or you cut it with lasers, sometimes that zinc will melt and come onto the edges, which will avoid the rust. But if you shear it, then this kind of problem comes. And with coating only, you have to do it. So usually, if you are doing powder coating, edge thickness is better, has to be better if the earthing and everything is in place. So in that case, that protection comes. But if this is going for CED, the edge protection becomes a problem, because edge thickness of paint on edges is a little thinner and it becomes a problem. If you are not coating it, then we will have to find some other way to avoid the rust on the edges. Mr. B.N. Gupta, is there any relationship in WFT versus DFT? Yes, I think I have explained it. It will tell you the volume solids of that paint will tell you what is uh, how much is going to be the DFT for that particular WFT. It is after evaporation of solvent, how much it comes is volume solids, and that you will find on the technical data sheet of the supplier. 3-in-1 cleaning is a recommended method for pre-cleaning or not, please suggest. Okay, nice question, very important question. None of the specifications, nor SSPC, nor NES, nor ISO is mentioning anywhere this 3-in-1 process. 3-in-1 should be done on something which cannot be either dipped into the chemical tanks, very big in size, or uh, which cannot be, which cannot be blasted. So up to say 1.5, 1.6 mm thicknesses, blasting becomes very difficult. There can be warpage of the material. Usually we say that above thickness of 2 mm, 100% above thickness of 2.5 mm, blasting can be done. Up to 2 mm plus, if it has a right framing, right strengthening, you can do blasting, but if it's a plain 2 mm sheet, you might find some warpages after blasting, because that blasting, we throw the media, that is shot or sand, at a very high speed, that is, which is about 500 miles an hour. So naturally, it will destroy the shape in certain cases. So there you can use 3-in-1. I mean, this is my suggestion. It is never written anywhere. It is better than doing nothing. So 3-in-1. 3-in-1 usually is a chemical, 3-in-1 phosphating, where degreasing, little bit of derusting, and a little bit of iron phosphating will happen in one go, single liquid. How to dispose the paint sludge? Okay, there are regulations by CPCB. This is by Mr. Pradeep Kumar Sharma. And there is another question also, is what is the content of the paint sludge? Normally this paint sludge which we collect in the booth water or even on the dry filters needs to be disposed of at the specified area by the government or pollution control board in your particular state. There is a CPCB guideline, that is Central Pollution Control Board guideline, that it should be delivered to them and then they will destroy it. We cannot do anything to that. We cannot burn it, or we cannot. Now, what are the contents if it is uh, in a dry filter type of paint booth? It will be something like dust. It has polymers which are polymerized, dried, then pigments and some additives. Solvent will evaporate. If you have a water curtain type spray booth, then naturally some solvent will evaporate, and place of the solvent there will be some amount of water in that. So up to 55% of water you can find in this slush. So usually people try that and then send it for the disposal. I think those are the questions up till now. I hope they are answered to your satisfaction. If not, you can ask the questions again, no issues. Now during coating application, okay, I think we had finished this slide. Now let's move to next slide. inspection of coating. Now, inspection of coating is very important at every stage of work, including surface preparation, mixing and thinning, and coating application. You have to report, write everything, record everything, and as well as you can have photographic evidences like what was the metal condition before. Then every stages also, whatever you do, you can take photographic evidences and you can record them as well. So they are, uh, I mean, for say failure analysis and all, they will be very helpful. Now, what are the commonly used protective coatings in the market? One is inorganic zinc silicate primer. Now, this is not very easy to apply. This is a moisture cure type. So, if you are in a very dry place, say in Rajasthan or some place like that in the summers, so that primer may take 4 days to dry and still would not cure 100%. Usually, uh, in such cases, they sprinkle water onto that and the curing happens here. This primer is also very good. This can withstand very high temperatures also up to 300, 400 degrees, 300, 250 to 300 it can definitely uh, take care of. Then zinc rich epoxy primer. This comes as epoxy base, epoxy hardener, then zinc powder separately and thinner. So again, very high protection. The zinc by weight is recommended by specification is 80% or some cases 85%. Okay, but by weight, zinc is having very high specific gravity, so naturally the volume will not be so much in a liter of paint. Then there are some multi-purpose epoxy primers. So this multi-purpose can be indoor, outdoor conditions, or they will have zinc phosphate or some kind of inhibitive pigments into that. Then epoxy polyamides normally are used for high-end laminations or tank inside lining or say water tank inside lining or something like that. A very effective and very good finish. Then acrylic aliphatic polyurethane top coat. I have specifically written acrylic aliphatic because in polyurethane the hardener is isocyanate. Now it can react with the hydroxyl group available in any polymer and form a chain. So even alkyd with that can also become a polyurethane paint, but that will not give you the right outdoor resistance. So better write that acrylic. Then aliphatic is, we are talking about the isocyanate. You can have aliphatic isocyanate as well as aromatic isocyanate. Now aromatic is something with a benzene in the ring. Aromatics are not stable. Aliphatics are stable. So naturally, if you use aromatic hardener or isocyanate as hardener, it is going to fail prematurely. Sometimes if you have white finishes, it may turn yellowish and then fail. So usually for good outdoor resistance, you can specify, you have to specify acrylic aliphatic polyurethane top coat. Then hybrid coal tar epoxy, usually coal tar will give you very good water resistance and it reacts well with epoxies also. This will give you a very good coating for certain things which are below the soil. So like pipelines and everything which are below the soil, we usually use hybrid coal tar epoxy. Modified silicone coatings again used for high temperature resistance up to 250, 300. Silicon aluminum top coats we are using up to 538 degrees centigrade. Why 538 is that is a direct conversion from 1000 degrees Fahrenheit to centigrade. So these types of coatings are used. I think there are a few questions. One from Damini Mehta. At 140 micron thickness, we are facing waviness problem. What should be the reason of that? Okay. Uh, See, 140 micron is a thickness which is not avoid your imperfections in the base metal. If the base metal imperfections are in mm, 140 micron is probably 14% of 1 mm. So it will not uh, hide 100% those waviness problems. Those waviness problems must be coming from your base metal. So just have a look into the incoming material. EPT is installed but not being used efficiently. How we can contribute to bring to notice of government on board level so that we can save our environment and reduce the pollution. Mr. Yogesh Chaudhary, good. I mean, happy with your concern with environment and the reduction of pollution. You can definitely how we can contribute to bring to the notice of government on broad level so that we can save our environment. Basically, to check this, there are people from pollution control boards, and it is their duty from government to look into these matters. Probably, I don't know the condition. Probably number of inspectors or number of people with pollution control board and against number of industries. I don't know the statistics. But you can definitely inform the local area pollution control board and they'll take a positive step to for this to happen. And I think good question. And Pradeep Kumar Sharma is asking how we decide the rod distance from surface in compressed air quality testing. It's 18 inches actually. So rod in the sense that nozzle distance is 18 inches and that is in that ASTM standard. So you don't have to decide, you have to follow. Mohit Vagela is using, can I use PU DTM paint of 1800 hours salt spray instead of current epoxy ZP primers and PU top coats? Okay. This is a new kind of paints which are being or are getting promoted in Europe and also in India. DTM is direct to metal and PU of course has good resistances, no doubt. And if they are or if you are sure if you have checked the salt spray and you are getting 1800 hours, you can avoid going for epoxy zinc phosphate or epoxy zinc rich epoxies and all. But ultimately that has to be between you and your end customers because most of the cases now I know Mohit Wagela is into manufacturing of their own proprietary products and they have their own proprietary specifications. So it will be easier for you to change. But people who are manufacturing and supplying it to somebody are bound with the specifications dictated by their uh, customers. So there it could be a problem. But yes, if you are getting, you are confident you have done this salt spray test in your results and you are happy with 800 hours, there should not be any technical issue for moving for DTM paints. Okay. The next is Mr. Digvijay Patel. After the powder coating, some components having black patches, particularly on white shade. How we can overcome this problem and how we can rework that components. Okay. Uh, it's very difficult for me to visualize what kind of white black patches you are getting. So what you do is try to take some photographs, post it on ecafes.com. Right hand side top, you can see that ecafes, www.thatecafes, same spelling.com. You send those photographs, so they will reach me ultimately. I'll have a look at it and then probably I'll be able to uh, give you a solution, tell you the solution. But most probably what I feel is this is of course not a powder coating session, but still since you have asked this question, uh, are your coaters who are handling the product after phosphating or after blasting to loading onto the powder coating conveyor wearing gloves and caps? If not, they are transferring some oils when they touch, and there you are getting very low thickness because of oil. There's some surface tension phenomena. You are getting a lesser thickness there, and probably you are looking it as a black patch. Okay, so just have a look at it. That should solve your problem. I think, uh, yeah. Okay, Mr. Mohit Waghela is saying, who had asked for DTM paint, you is just saying, okay, thanks, sir. So next, epoxy primers are the most widely used anti-corrosion coating. So when it comes to anti-corrosion coating or when it comes to protective coating, we talk about epoxies as primers. Epoxy is most preferred type of anti-corrosion coating owing to its good corrosion protection, temperature, chemical and water resistance and adhesion to steel. But there are some others also, like you have chlorinated rubbers, polyurethanes, alkyds, acrylics and other type of new generation coatings are there. But I think in all these, as of today, epoxy scores the best. Now there is a lot to cover actually in this topic. I have taken a small effort to introduce you with the topic of corrosion protection and the depth of it. Probably this is the end of my presentation. Anybody has any questions? Please go ahead because we have another 10-15 minutes to available with us. So anybody wants to ask any questions, please go ahead. No, most of all the questions till now are already answered. So I've just requested everybody for any more questions. So we still have 10 minutes on our hand, so we can address those. But I think you can finish it. But you still
Yes, last questions.
Yeah, I have got two more questions. From Mr. Yogesh Chaudhary, what is recommended mixing ratio of powder coating with recycled powder? Thickness is 70 microns. Usually, ideally recommended by all powder suppliers is 80-20. Especially if it is glossy powder or if it is texture or structure powder, stick to 80-20. If you are doing plain satin finish or matte finish, blacks or grays, you can go up to 70-30, but not beyond that. Then there is one more question from Mr. Pradeep Kumar Sharma. Can air dry paint be baked in oven or not? Okay, yes. Basically, not all, but there are some paints which you can put in oven. It is not called as baking. We call it as forced drying. Usually at 70 or 80 degrees centigrade, as I have already informed you that the reactions will speed up when we increase the temperature. So this particular hardener to base reaction will definitely increase if you increase the temperature. So when I was talking to you about that, painters might misguide to tell you that add some more thinner, some more hardener so that drying will be faster. Instead of doing that, if you do this, elevate the temperature of that particular job by keeping it in oven or some place where temperature is higher. You can definitely dry the paint faster than recommended. So usually something which take 4 hours to dry. I'm talking of in case of 2K paints, 2 component paints. 4 hours at normal ambient conditions. Keeping an oven at 70 to 80 degrees, you usually get them dry in half an hour, 30 minutes. So you can definitely save time on that. Mr. Saurabh Srivastav is asking what process follow in dual powder coating process. I think a lot of people are interested in powder coating. Dual powder coating is usually the first coat is like zinc rich primer only. Only thing is it is in a powder form. So if you look at their specifications also, they'll ask you to uh, bake it at little lower temperature, usually 160 to 170 degrees, so that that epoxy is not fully cured. Then you apply the second coat and again it goes for baking. That time the first primer coat is baked. So usually that is how we use it. In nylon powder coating at 140 micron thickness, we are facing waviness problem. What could be the possible reason? I definitely don't know this particular thing. Basically, nylon powder is a thermoplastic powder. So probably even if it is getting applied properly, but when in oven, this waviness could be formed. So unless and until I can see the photograph at least, I'll not be able to give you an answer. So please try to take photographs and post it on ecafes.com, and I'll have an opportunity to have a look at it. Then probably I'll send a mail to you, a solution to you through ecafes.com. We have not blasting or power tool facility. We are using 3-in-1 chemical. I've checked cross-hatch test. Adhesion is fast. So is it good for using 3-in-1 chemicals before priming? Mr. Mohit Wagela. Mr. Mohit, basically, in case of high-end corrosion resistance, only the cross-hatch test is not applicable. We are doing one more test which is called as adhesion pull-off test, where we just press the dolly and pull it with hydraulic force and check how much hydraulic force it passes or it fails. So that is slightly a more stringent case, and your case, you if you need to improve, I think 3-in-1 will not give you the right pull-off test as well. So this can be thought upon. Okay. What is the root cause of orange peel? In liquid orange peel, root cause is different. In powder, root cause and for orange peel is different. In liquid paints, usually it again depends on what is the spray gun you are using. Number two, what is the distance of spray gun from job? See, if we hold little away, naturally whatever thinner is there is going to evaporate and flow is not going to be correct. So basically you need to train your painters. Then you need to check the drying time, because the drying time in winter will be different. Drying time of thinner in summers will be different. Automotive industry, almost most of the places in India, 100% in North, are using some thinner, different thinner in winters and different thinner in summer. And what is the difference in that? It's just the drying time of thinner. Basically, they have to control this orange peel or flow, or what we call as DOI, distinctness of image. So there are requirement of SPT, salt spray test of 2000 hours. What are the options? Mr. B.N. Gupta. Sir, what are you doing actually? I mean, is it powder or liquid? Hmm? Okay, just type it out. I'll come to that. No, it's okay. It doesn't depend on the Mr. Gupta. Mr. Gupta. Hello. Hello, Mr. Gupta.
Hello.
I can listen to your voice. Please speak.
Hello.
B.N. Gupta.
Hello.
Yeah.
Yes, sir. Hello.
Yes, yes. Continue. I can hear you.
Yes, sir. I'm not using any pen, but most of my customers who are supplying to say some van engineering components are like that.
What component?
So
Please repeat.
they supply to marine engineering, like shipping corporation and like that.
Mm-hmm.
And for that kind of a product, they require some certificate test of say 2000 hours, 1500 hours,
There's
like that.
nothing in particular liquid coating or powder coating. Hello?
Uh,
Nothing in
I'm just asking
particular about
options.
powder coating or liquid coating.
What are the options for liquid coating or powder coating? Uh,
Powder coating, if you go for the dual system, what was discussed earlier, you
mhm.
can cross 2000 hours of salt spray, number one. Or for liquid, you'll have to go to four coat system. Four coat in the sense, first coat will be the zinc metallizing. It's actually
Zinc
zinc
metallizing.
metallizing on that, and then three coats. So, which can
Okay.
bring you to near about to 2000 hours. Okay.
Yes, sir.
Anybody has
Thank you.
anything in particular, your customers, please guide them to our ecafes.com and ask the particular question, because this is a very general question and very difficult to guide, to answer actually. Mr. Gupta,
Yes, sir.
yeah. If they have any
Hello.
questions, please specific questions ask on ecafes.com so we can tackle them specifically, because it cannot be a general answer for this question. Okay. Hello. Hello.
Hello.
Hello.
Hello.
Hello. Yes.
Hello.
Hello. Am I clear to you? Can you hear me? Hello. Next is Mr. Yogesh Chaudhary asking about advantage of tricatonic over dicatonic. Basically, tricatonic is a next generation phosphating, and it has some amount of hydrogen fluoride also, which will give you good etching of metals and then coating. So it has certain advantages, shorter takt time also, uh, and what I should not tell you, but higher price, so higher margins for the suppliers. So people are promoting. But anyway, I think 2022 phosphating is going to get banned. Okay, in Europe. So by 25, it should get banned in India also. So phosphating also is a process which is under scanner. It will get. Mr. Pradeep Kumar Sharma, what is the recommended PT process on GI sheet for powder coating? Okay. Again, not a question related to our topic, but there's something called as chromatizing. So GI sheet, you should do chromatizing and then do powder coating. You'll get good results. Chemical suppliers will have chromatizing chemicals. If in three-coat system of paint, Mr. Anand Bhagwat is asking, if in three-coat system of paint, after surfacer coat, there is a gap of 12 to 14 hours. How to apply final coat of PU? Because after surfacer coat, there is a gap of 12 to 14 hours. Gap of 12 to 14 hours in the sense, it's recommended gap by the supplier, or because of the shift timing and all, you have to wait for 12 to 14 hours. If usually 12 to 14 hours is not an issue. I'm talking of people will primer it, keep it for 3 months, 4 months, and then take it for top coat. That time they might face a problem. 12 to 14 hours is a safe timing. Mohit Wagela again, so might be not apply pull off test. Yes, I mean, I'm not saying pull off test is applicable for you. I just gave you that if we have to do a pull off test, the corrosion conditions are literally C5I or C5 marine. So in that case, we usually do these pull off tests. So if your products are not going to such severe conditions, you need not have to do that. So whatever you are doing as of today is serving your purpose, and try to find out customer complaints. Your customer might not complain, but your service person, whenever he goes and attends that machine or equipment, you can just ask him to take photographs and send it to you. So you will get some idea what to do. As Mr. B.N. Gupta is asking liquid. Okay, we have talked to Mr. B.N. Gupta. Mr. Anand Bhagwat is saying due to shift timing. Okay, that's not an issue. 12 to 14 hours is not an issue. But again, what you do is you talk to your paint supplier and get a confirmation in writing usually. There should not be any problem. Okay. Mr. Mohit Wagela is saying thanks a lot, sir. And I think there's only 1 minute to go. Anybody with any questions unanswered or unsatisfied? Probably I might have missed on some of the questions. I don't know during the discussions. Okay, Mr. Mohit Wagela, thank you. He is saying very fruitful webinar. This is good. Thank you. Thank you for joining us, and thank you for giving your reply as well, appreciating us. So it's a continuous effort on part of Tata Steel to uh, educate their customers. This is a first webinar, in fact, which was free to all. I mean, not only for the customers. So this basically they are trying to widen up the knowledge base, which is very good. And thank you very much to all of you. I could connect to all of you through this ecafes.com, Tata Steel, and I would request Mr. Sanjay Behra from Tata Steel to close the program. Thank you. Over to Mr. Sanjay, sir.
Thank you so much to all our audience for listening to and participating in this session of webinar. This is sixth webinar, and we will organize more such which is relevant to the customer manufacturing process. How we can help the customer to improve their productivity, which will help them to compete in the market and also improve their competitive benchmarking in the in their product range. Thank you very much for your good cooperation.